Hello. Right, so in this one, we're kind of doing the same as the last video here, but we're just looking at pension repayments. More specifically, we're going to be using some of the geometric series and like present values to find out, well, how much money do I need to have at the start of my pension in order for me to be getting a certain repayment every month, right? So like I'd be like, okay, how much money do I have saved on the day of my retirement in order for me to get a pension of €1,000 a month? You know? So let's look at that here. So just like savings, we can use a geometric series to model pension repayments. This time we want to find the initial investment P needed to provide regular future payments or fixed amounts F. So if multiple payments are made, e.g. Monthly pensions, the total present value is the sum of several discounted payments, forming a geometric series. So, what we need to do here is I need to find what the present value is of my pension. So if I'm making X amount of payments into my pension, the sum of all them present values equals to what I need at the start of my pension. So let's have a look here. You are due to receive annual payments of €10,000 for 10 years, starting in 4 years. What is the present value of these payments if the annual interest rate is 5%? Well, annual payments and interest rate 5%, so I don't need to change my interest rate here. So let's look at here. So my starting amounts. So my interest rate is 0.05. My time here, or N, it seems to be 10 years, right? Or 10 repayments. So you have to think about this now. I am getting paid. I'm starting my 10-year pension in 4 years. So I'm due to receive €10,000 for 10 years' time in 4 years. What is the present value of these payments? So how many years is my first payment accruing interest for? Well, I'm not getting it for 4 years. Therefore, my present value of my first payment is 10,000 over 1.05 to the power of 4, right? My second payment is going to be 1.05 to the power of 2. And then finally, my last payment then, so not power of 2, sorry, power of 5, right? My last payment then will be, so I'm receiving an annual payment of 10,000 for 10 years. So my 10th payment will be, so 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, right? So it's 13 years. So in 13 years, I will receive my 10th and final payment. So that's going to be 1,000, right? All over 1.05 to the power of 13. So let's apply my geometric formula here. So A being 10,000 over 1.05 to the power of 4. My my common ratio is just going to be 1 over 1.05. And then my N is going to be equal to, so that's how many terms do I have here? I have 10 terms, okay? I have 10 terms here, so it's not going to be 13, it's going to be 10. And then let's plug it into my formula. So when I plug these into my formula, I get right. So if I plug them into my formula, I get here. So A minus 1 minus or to the n all over 1 minus or. So that's 10,000 over 1.05 to the power of 4 times 1 minus 1 over 1.05 to the power of 10 all over 1 minus 1 over 1.05. 66,703. So my pension, right now, my pension's worth 66,703. 6,730. That's how much I need to have my pension in order to get then 10,000 a year for 10 years, starting in 4 years. And let's look at one exam question here. So Acme Confectionery has an employee pension plan. For an employee who qualifies for the full pension, Acme Confectionery will pay a sum of $20,000 on the day of retirement. It will then pay a sum on the same day each subsequent year for the next 25 years. The year the employee is paid a sum that is each year, the employee is paid a sum that is 1% more than the amount in the previous year. What is the sum of money that the company must set aside on the day of retirement in order to fund this pension? So, i.e., we are finding out what is the present value of this pension on the day of retirement. So, year one, we have to think of it like here. Year one, they're paying out 20,000, right? Year two, right? That's the present value. In year one, I'm getting it on the day of retirement, right? So on the day of retirement, that 20,000 accrued, no interest, no nothing, no growth, no nada, right? So that is worth 20,000. That's my present value, 20,000. Year two, however, right? Well, first of all, it's going to be 20,000. It said it's going to be 1% more, right? 1% more than the previous year. But then I have to find the present value, so that means I have to divide it by the interest rate. So in this case, it will be, the annual interest rate is 2.4%. So it's 1.024 right, to the power of 1, because that was only kind of accruing interest for 1 year. Year 3 is going to be 20,000 times 1.01 squared all over 1.024 to the power of 2, right? Because it's been accruing interest for 2 years. And this keeps going, ... until we get to the final year. So this is for the next 25 years. So actually, there is like 26 years, right? So it says here you'll receive 20,000 and then each subsequent year for the next 25. So there's 26 payments. It'll be 20,000 to the power of 1.01 to the power of 25 all over 1.024 to the power of 25. This is my geometric series. So A being 20,000. My OR is 1.01 over 1.024 because that is what I'm multiplying to get to the next term. And then T is equal to 26, or N is equal to 26 because there's 26 terms here. So Sn equals A times 1 minus OR to the N all over 1 minus OR, which is 20,000 times 1 minus 1.01 all over 1.024, the power of 26, all over 1 minus 1.01 over 1.024, which is equal to 440,132 euro and 40 cents. So, in order for Acme Confectionery to pay out a pension of 20,000 a year for the next 25 years, and each year being 1% more than last year, in order to do that, they need to have 440,132 euro and 40 cents saved on the day of retirement, right? And I will leave this video here. It's a bit tricky to get your kind of head around, but it's best to kind of practice more exam questions with this. And I hope this video was some help to you guys. And I'll catch you guys later. Bye.